Hello friends, let's enter into our new chapter, probability. Okay, so before entering into this chapter, let's have a brief introduction to this. So first of all, what is meant by probability? We have gone through this chapter in our class 9 also, but let us recap the same thing which we have learned before. Okay, so what is probability? Probability is nothing but the likelihood of occurrence of an event can be quantified. Okay, such quantification into numerical measure is called probability. Okay, first of all let me write it whatever I have said to you till now. Okay, the likelihood of occurrence of an event can be quantified such quantification into numerical measure is called probability. Okay, this is the definition of probability, and this probability is based on estimations only. Based on estimations only. Okay, so this is the theoretical concept of probability meaning. So first let me explain this definition with the help of an example. Suppose when you toss a coin, let us suppose this as one coin. Okay, this is rupees 1. When you toss a coin, there is a probability of getting a head and there is also a probability of getting tail. Okay, so when you toss the coin 10 times, you may get head as 5 times you may get, and 5 times as tails, or else 4 times as head and 6 times as tails. Okay, so whatever the outcome you get each time is different from the outcome when you perform second time, third time, and so on. Okay, so there is no necessity that the same outcome you'll be getting every time when you perform the experiment. Okay, so this probability is based on estimations only. Once you do the actual experiment, the outcome may be different. So that's why whatever we are making the probability, that is based on estimations only, that is based on assumption, estimation. Actual is different from the estimation. Clear? So suppose in the first example I told you that the probability of getting heads is 5 times and probability of getting tails is 5 times. So what is the probability value of getting head in this event is, so nothing but how to find out the probability of getting heads in this experiment. How many times you got heads? I told you 5 times you got heads. What is the total number of outcomes here? That is, total number of outcomes is nothing but total number of times you have tossed the coin. It means 5 times you have got head and 5 times you got tails. It means how many times you tossed the coin? It is totally 10 times. Okay, 10 times you tossed the coin, out of which 5 times you got head and 5 times you got tails. So probability of getting heads is nothing but number of times you got head by total number of outcomes, that is total number of times you tossed the coin. So what is the probability? So it's nothing but it is 1 by 2, which can be written as 0.5. So this is the 0.5 is the probability of getting head when you toss the coin 10 times. That is the meaning of the probability here. In the same way, what is the probability of getting tail? Number of times you got tail, it is 5 by total number of outcomes. It means nothing but total number of times you tossed the coin, it is 10 times. So it will be again 1 by 2, which is 0.5. So 0.5 is the probability of getting tail in this case. So this is the probability in the example 1. In case in the example 2, I told you that 4 is the probability of getting head and 6 is the probability, and 6 is the number of times that you'll get tail when you toss the head 10 times. Okay, out of 10 times, 4 times you'll be getting head and 6 times you'll be getting tail. So what is the probability of getting head here? It's nothing but Number of times you got heads, that is 4 by how many times you tossed the coin, that is total number of outcomes is nothing but 10. Okay, it becomes 2s are 5s, that becomes 0.4. Okay, so what is the probability of getting tail here? It's nothing but 6 times you got the tails out of 10 total trials, so it become 0.6. So this is the way how to compute the probability value. Okay, so let me give you a recap again. So when you toss the coin 10 times, you'll be getting, in this example 1 I'm telling, this example 1, when you toss a coin 10 times, you'll be getting 5 times heads and 5 times tails. So when you got 5 times as heads and 5 times as tails, what is the probability of getting heads is nothing but 5 times you got heads. So 5 by how many times you tossed the coin? I told you that 10 times. 10 times you tossed the coin. So 5 by 10. That's nothing but total number of heads you got by total number of outcomes. Okay, that is called outcome. That is nothing but result. Okay. How many results you got means 10 results you got. In that 5 as heads and 5 as tails. So 5 by 10 in each case you'll be getting 0.5 as heads probability of getting head and 0.5 as probability of getting tail. In the same example 2 also. Clear? So this is how we'll calculate probability value in terms of numerical measure. Okay. This is the probability value. Clear? See here, we have tossed the coin 10 times, then we can measure the result. If we toss the coin 100 times, 1000 times, 10,000 times, when the tossing is more, it means when you perform the experiment multiple times, then counting the outcomes is a bit difficult. So that's why we have to make an assumption that what is this probability chapter itself is based on estimations. So one assumption you have to do is that all the outcomes are equally likely. Okay, equally likely outcomes. This is the assumption you have to do. What is meant by equally likely outcomes? Suppose when you toss the coin, the assumption is that there is a equally likely chance of getting outcomes. It means what? There is equal chance of getting heads and equal chance of getting tails. There is no biased coin. That is the meaning. Okay, this assumption is that equally likely outcomes means there is equal chances of getting heads and tails. I am explaining you with the help of the toss, that is coin toss only, because when you take the same example and explain each, so that you'll understand the concept very good. Clear? So one assumption is this is based on estimations only, and the other one is all the outcomes are equally likely. There is no biased. Clear? So there is another definition called a theoretical probability. Theoretical probability, or this is also called as classical probability. It's nothing but probability itself, but there is an assumption of all the outcomes are equally likely, and the formula for this is theoretical probability formula is probability of an event equals to number of trails or outcomes in an event, number of trails or outcomes in which event occurs by total number of trails or outcomes. Clear? So probability of getting an event equals to number of trails or outcomes in which event occurs. Okay, number of trails, it means number of outcomes in which the event happens by total number of trails or outcomes. If I suppose, let me toss a coin. Okay, I am telling you again tossing a coin, because when you toss a coin, chances of getting head. Okay, chance of getting head, it's nothing but 5 times you got, and 10 is the total number of outcomes. Same thing, same formula. This is the general formula for finding the probability of an event. Clear? Here H is an event and tail is an event. Clear? Two events are there. And The answer will be depending upon this formula only. Number of trails or outcomes in which the event occurs. So number of outcomes 5 times by total number of trails or outcomes. Clear? So this is the formula for the probability. This is also called as theoretical probability or classical probability. Clear? Now mutually exclusive events. What is meant by mutually exclusive events? So mutually exclusive events are nothing but the occurrence of one event prevents the occurrence of another events. Suppose when you toss a coin, you will be getting either heads or tails, but you can't get both. Okay, you will be getting either heads or tails but not both. So here the occurrence of heads prevents the occurrence of tails. Then these two events are called mutually exclusive events. Okay, so when you toss a coin, you'll be getting either heads or tails, but you can't get both. So in such a way, the probability of occurrence of an event that is head, the probability of occurrence of head event prevents the probability of occurring tail event. Okay, so let me write it now. Two or more events of an experiment where occurrence of an event prevents the occurrence of other events. So when the head is occurred, the tail will not become correct. So then these two events, head and tail events, are called mutually exclusive events. So let me write it now. Two or more events of an experiment where occurrence of an event prevents occurrence of all other events. Then such events are called mutually exclusive events. So I'm writing it in short form. Okay, for making you the concept understanding clear, I'm explaining each and every concept with the help of corn toys only, if it's applicable, or else I'll move on to the next example. Okay, so in this example, when you toss a coin, you'll be getting either heads or tails but not both. It means two or more events of an experiment, two events I've got no, where occurrence of an event prevents the occurrence of all other events, then these two events are called mutually exclusive events. So this is the concept. Now one more thing, what is sample space? It's nothing but whatever the probabilities of outcomes you are getting, then all those outcomes comes under sample space. Suppose when you toss a coin, what will be the outcomes? Will be get heads and tails. One coin toss will be getting heads and tails, correct? So these outcomes is whatever the set of outcomes are called a sample space. Okay, this set of outcomes is called a sample space. For suppose when you have a bag in which there is red pen, black pen and blue pen. Okay, 3 pens are there. When you take one pen each time, so what will be the possibility of outcomes here? First time you will be getting any blue pen, second time you will be getting black pen or red pen. So 3 times when you take, you will be having 3 different possibilities, correct? You will be getting either black, either blue or red. Okay, so what will be the total number of outcomes? Will be only 3. So these 3 are called, this 3 is called sample space. So what are the possibilities of outcomes? Then those set of outcomes is called a sample space. Okay, this is one concept.